Hello friends, welcome back. Hearty welcome to you. In this session, let us look at the condition for orthogonality for system of circles. Now, earlier we have derived the formula to find out the angle between two circles, that is given by cos theta equals to d square minus r1 square minus r2 square divided by 2r1 r2. I will give the link in the description. If you haven't seen that video, I request you to go through that video, then come here. Then it will be easy for you to proceed. You will understand how this formula is derived. Okay. Now condition for orthogonality means we are talking about theta equals to 90 degrees. Now what happens when theta equals to 90 degrees? When theta equals to 90 degrees, cos 90 is 0. So we will have 0 equals to d square minus r1 square minus r2 square divided by 2r1 r2, or we will have d square equals to r1 square plus r2 square. Now let us see, can we simplify this by taking two circles and see what will be the condition for orthogonality. Now let's take two circles. One circle is x square plus y square plus 2g1x plus 2f1y plus c1 equals to 0. Another circle is x square plus y square plus 2g2x plus 2f2y plus c2 equals to 0. Let us find out what is d, what is r1, what is r2, so that we can substitute those values. First let us see what are the centers of these circles. I have minus g1 minus f1 and minus g2 minus f2 are the centers of the circle. So d will be the distance between them, or can I write down d square equals to g1 minus g2 whole square plus f1 minus f2 whole square. That is the formula for d square. What is r1 square? Let us see. r1 square is g1 square plus f1 square minus c1. Similarly, r2 square is equals to g2 square plus f2 square minus c2. Now let us substitute these values of d square, r1 square and r2 square into our cos theta and see, can we get a formula in terms of g1, f1, g2, f2, c1, c2. After that we will go back to this particular formula, d square is r1 square plus r2 square. Then we will try to get the condition for orthogonality. After that we'll try to do some problems based on this particular concept. Let us substitute. We will have cos theta is equals to d square, that we know already, g1 minus g2 whole square plus f1 minus f2 whole square minus of g1 square plus f1 square minus c1 minus of g2 square plus f2 square minus c2 divided by 2 into square root of r1 is g1 square plus f1 square minus c1 under root. Similarly, r2 is g2 square plus f2 square minus c2. Let us simplify this in the next step. Let's open the brackets and try to simplify this. So what we will have, let us see. We will have cos theta is equals to, open the brackets, we'll have g1 square plus g2 square minus 2 g1 g2 plus f1 square plus f2 square minus 2 f1 f2 minus g1 square minus f1 square plus c1. Then we will have minus g2 square minus f2 square plus c2. This whole thing divided by 2 into square root of g1 square plus f1 square minus c1. Multiply that with g2 square plus f2 square minus c2. Simplify this. That will be our final step for the formula to find out the cos theta value. It will be cos theta equals to, now we can clearly see that we can cancel g1 square, g2 square, f1 square, f2 square. What is left out is c1 plus c2 minus 2g1 g2 minus 2 f1 f2 divided by denominator 2 into root of g1 square plus f1 square minus c1. Multiply that with g2 square plus f2 square minus c2. Now this is the formula what we are going to use to get now condition for orthogonality. So let's go to the next step. Now what happens when theta is 90 degrees? When theta is 90 degrees, cos 90 is equals to 0 and 0 is equals to c1 plus c2 minus 2g1 g2 minus 2 f1 f2 divided by square root of g1 square plus f1 square minus c1. Multiply that with g2 square plus f2 square minus c2. Now denominator will become 0, so that will give us 0 equals to c1 plus c2 minus 2g1 g2 minus 2 f1 f2. So we will have 2g1 g2 plus 2 f1 f2 is equals to c1 plus c2. This is the condition for orthogonality of two circles, what we have to remember. So this is the formula for finding the angle between them, and this is the formula for proving the condition of condition for orthogonality between two circles. Now let us do some problems based on these two formulas. Now let us try to solve some problems based on this. The first problem we are going to do is this one. The first bit. Find the angle between the circles given by the equations. Now whenever a circle is given, always try to write down x square plus y square plus 2gx plus 2fy plus c equals to 0. That will give us what is the value of g1, g2, f1, f2 and c1, c2. Now look at this particular circle. We know 2g equals to minus 12. So g1 is equals to minus 6, f1 equals to minus 3, g2 equals to 2, f2 equals to 3, c1 is 41, c2 is minus 59. Let us substitute in the formula. Understood how we got g1 and g2? Let me repeat that again. X square plus y square plus 2gx. 2g is minus 12, then g is minus 6. 2f is minus 6, f is minus 3. C is 41, so c1 is 41. 2g2 is 4, so g2 is 2. 2f2 is 6, f2 is 3, and c2 is minus 59. Now simply we have to substitute in the formula. We can write down cos theta is equals to c1 plus c2, that is 41 minus 59 plus minus 2 into c1 plus c2, that is 41 minus 59, minus 2 into g1 minus 6 into g2 2, minus 2 into f1 minus 3 into f2 3, divided by 2 into square root of g1 square plus f1 square minus c1, that will be 6 square plus 3 square minus c1, that is minus 41, and here it will be g2 square 2 square plus f2 square 3 square minus c2, that will be plus 59. Let us simplify this. What we will have? First let me go to denominator. In the denominator I can see 2 into 6 square is 36, 36 plus 9 is 45, 45 minus 1 is 4, so that is square root of 4 is 2, and 4 plus 9 is 13, 13 plus 59 is 72, square root is 6 root 2, that is root 72. Let's go to the numerator. What you have in numerator is 41 minus 59, then we have plus 24, then we have plus 18. So let us simplify that. We will have 24 divided by 24 root 2. Now 24 will cancel, that will be 1 by root 2. So cos theta is 1 by root 2, that means theta equals to pi by 4. So the angle for the first one is theta equals to pi by 4. Let's go to the next problem now. You can pause the video and try the second bit, but if you want to do with me, let us do it together. I suggest, since you have done one problem, you know what to do. You can pause the video and try this problem on your own, and you can check the answer afterwards from the video. Okay, if you want to do with me, let's go ahead and do the second bit now. In the second bit we have 2g1 equals to 6. We are doing this bit now. So g1 equals to 3. By this time you are very clear with that. f1 is minus 5, c1 is minus 135. I have g2 equals to minus 2, f2 equals to 7, and c2 equals to minus 116. Again we have to write down the formula for cos theta. So let's substitute in cos theta formula. Cos theta equals to c1 plus c2 minus 135 plus c2, that is minus 116, minus 2 into G1 into G2 minus 2 into F1 into F2 divided by square root of G1 square plus F1 square minus C1, that is 3 square plus 5 square plus 131. Multiply that with 135, right? That's a mistake. 135 and G2 square plus F2 square minus C2, that will be 116. Let us simplify this. We will have, let us simplify the numerator first. We have minus 135 minus 116. This is minus 251. Remember that. We have 6, 12, 12 plus 70, 82, and here it is minus 251. That means we have minus 169. So I can actually write down more steps on that, but due to space constraint I am trying to cut down the steps. Hopefully you will understand that. And here let's look at the denominator now. 9 plus 25, 34. 34 plus 135 is 169. That means square root is 13. Again, let's go to the next one. 4 square plus 49 is, sorry, 2 square plus 7 square is 4 plus 49, 53 plus 116, 169. Square root is 13. So I can write down another 13. Now 13 will cancel. What you are left out is minus 1 by 2. Cos theta is minus 1 by 2. Then theta value will be how much? Theta is 1 by 2. So cos theta will be minus 1 by 2. Theta is pi minus pi by 3. Second quadrant it will be, that will be 2 pi by 3. Let's go now to the next problem. The next problem is, show that the angle between the circles 1 and 2 is 3 pi by 4. Let's go ahead and write down what is our G1, G2, F1, F2 so that we can finish this problem. First circle, when I look at, I have G1 equals to 0, F1 equals to 0, and C1 equals to minus a square. Remember, always we should have on the right side equals to 0 in this approach. So similarly, when you go to the next one, we will have G2 equals to minus a by 2, F2 equals to minus a by 2, and C2 is equals to 0. Now how we got that? Let me take one more step and write down here. What is given to us is actually x square plus y square minus a square equals to 0. Another equation is x square plus y square minus ax minus ay equals to 0. Now compare these two with our standard equation, that is general equation, we call it as, not standard. X square plus y square plus 2gx plus 2fy plus c equals to 0. What I was talking about earlier is right hand side should be equals to 0. Everything should be there on the left hand side. Now once we got G1, F1, C1 values, let's go ahead and substitute in our formula. Cos theta equals to, by this time you remember the formula, C1 plus C2, that is minus a square. I'm not writing down the formula now, directly I'm substituting, minus 2 into G1 into G2, then minus 2 into F1 into F2 divided by square root of g1 square 0, f1 square 0, minus c1, that is plus a square, multiply that with g2 square a square by 4 plus f2 square a square by 4 minus c2, that is 0. So let us simplify this and see what happens here. This will be minus a square in the numerator, because anything you multiply with 0 will be 0 only. In the denominator, you can see for the first square root a, and for the second square root we will have 2a square by 4, that is a square by 2. So that will be a by root 2. Can you tell me why are we not getting it? Because we have forgotten 2. Sometimes I am dumb. Most of the times I should admit. Okay. Now simplify this. This guy will become minus 1 by root 2. Now cos theta is minus 1 by root 2. Then theta will be how much? 3 pi by 4. Because cos is negative in second quadrant, all silver teacups. This is what I was taught in 1986 when I am studying trigonometry. Second quadrant, it is only sine and cosecant which are positive. Cos is negative there. So first quadrant angle is pi by 4. So the angle in the second quadrant will be pi minus pi by 4. That is 3 pi by 4. Therefore cos theta is minus 1 by root 2. That means we can write down theta equals to 3 pi divided by 4. So that is how we can show this, we can complete this problem. Now let's go to the next bit. The circles given by the following equations intersect each other orthogonally. So let us again go back and write down what is our g1 g2. What is the formula we have to apply? 2g1 g2 plus 2f1 f2 is equals to c1 plus c2. That is the formula we have to check whether LHS is equals to RHS. So let us write down the circles what we have. X square plus y square minus 2x minus 2y minus 7 equals to 0. And the other one is x square plus y square minus 8 by 3x. Remember, always you should divide with 3 or 2, whatever the number you have. Your a and b should be equals to 1. That means, to be simple, your quotient of x square y square should always be 1 before we apply this formula. So that's why dividing with 3, it will become plus 29 by 3 y is equals to 0. Now let us substitute the values of g1 g2 f1 f2 c1 c2. Now in the formula we have 2g1 into g2, right? So let's find out g1 g2. g1 is minus 1, f1 is minus 1, c1 is minus 7, g2 is minus 8 by 6, f2 is 29 by 6, c2 is 0. Let's go to the next step. LHS will be 2g1 g2 plus 2f1 f2. That should be equals to c1 plus c2. Now 2 into g1 minus 1 into g2 minus 8 by 6 plus 2 into f1 minus 1 into f2 29 by 6. On the right hand side is c1 minus 7 plus c2 is 0. That means I will have 8 by 3 minus 29 by 3 that is equals to minus 7. Minus 7 is equals to minus 7. So we have proven that these circles cut each other orthogonally because LHS is equals to RHS. Let's go to the next problem. Next problem, let's write down G1. We are doing this bit now. G1 is 2, F1 is minus 1, C1 is minus 11, G2 is minus 2, F2 is minus 4, and C2 is 11. The formula is what we need to apply is written here. 2g g1 g2 plus 2 f1 f2 equals to c1 plus c2. Substitute LHS 2 into g1 2 into g2 minus 2 plus 2 into f1 minus 1 f2 minus 4 is equals to c1 minus 11 plus c2 11. I can see right hand side is 0. Let us check left hand side is also 0. We have minus 8 plus 8. So 0 is equals to 0. So hence it is verified. We have shown that these two circles intersect each other orthogonally. Let us do one more type of problem. That's a final for this particular session. That problem is of where they give you these circles cut each other orthogonally with some variable k value or constant k value. We need to find out the value of k. So that is another type of problem. With that, we will wrap up this particular video. So we have 4 bits here. What I have done, I have given the k values for all of them. I'll be trying any one of this 4th bit. Remaining 3 you can try because I have given the k values. What will be the answer? You can cross check whether you got it right or not. They are easy problems. So let us pick this problem. We will do this one now. I will show you this. Remaining you can try. Let's go ahead and write down. We have x square plus y square minus 5x. So g1 is minus 5 by 2. Then minus 14y, that means f1 is minus 7, c1 is minus 34. Let's go here. 2x is 2gx, that means g is 1 and g2 is 1, I mean to say. f2 is 2 and c2 equals to k. What is the formula we have to substitute? For condition for orthogonality is 2g1 g2 plus 2 f1 f2 is equals to c1 plus c2. In some textbooks, instead of g1 g2 they use g into g dash. Anything is pretty much fine. The concept is important. It doesn't matter whether you use g1 g2 or g dash. It's only for your convenience. 2 into minus 5 by 2 into g2, that is 1, plus 2 into f1 minus 7 into f2, that is 2, equals to c1 minus 34 plus c2, that is k. Let us simplify this. This will be minus 5, then minus 28 equals to minus 34 plus k. Or can we simplify and say k equals to 34? We'll go to the left hand side, minus 33, or k equals to 1. So this is what we have done. K equals to 1. What I request you is try the remaining bits 1, 2 and so that is about system of circles. With respect to that, we have covered the concept condition for orthogonality, concept and examples. We have looked into problems where we found out the angle between two circles. If the circles are orthogonal, then we found the value of k. We also shown that two circles are orthogonal by applying the formula 2g1 g2 plus 2f1 f2 equals to c1 plus c2. In the next session, we will talk about, or we will discuss, or we will learn about radical axis. what is radical axis for two circles, afterwards also briefly about the radical center. So that will be the next topic. Thanks for your time and support. Bye for now.